Please join me for part 2 of the K8200.
No, it's part 3.
Part 3?
I said part 3 in the briefing.
I thought you said in the production briefing it was part 2.
No wonder you can't get any videos out. Keep fucking
Okay,
cocking up.
alright. Fine. I got it.
Get it right, or I'll sack you. I could get used to this producer in your ear gig. Let's see. This is ground control to Major Tom. Oh yeah, that's got a nice ring to it.
Please join me for part 3 of the K8200 build, where we make a breakout board for the back of the extruder module so we can experiment with other units without having to cut into hard wiring. Let's hit the bench.
Finally.
Well, I guess the next step would be to take into account how many wires we need or how many cables we need going from the control board up to this extruder breakout board here. Now, just probing around on the board, I've ascertained that the positive terminals on the heater 1, heater 0, Heatbed, obviously the power in, the fan connector and the auxiliary output or input here, they all have common positive terminals. So that means whatever shares a common positive terminal here, we can go up on the breakout board with perhaps 1 or maybe 2, probably separate out the high current load wires from the smaller current load wires, like running the fans and all that sort of business. So that will cut down the amount of wires that need to go up to here, but you'd have to be mindful on documenting what you do carry up to this board. So yeah, just be mindful. You don't have to carry every single wire up. You can use one wire for ganged polarities if you like. So yeah, I'm just going to confirm those connections. So the heated bed terminal positive. Okay, it's a good idea to not check the terminal blocks, because if you haven't got a wire screwed down in there, these screws don't become live. So we'll just flip that board over so we can get a better indication of what's going on. So heat bed positive to heater output 1. Oh, sorry, heater output 0. That's common. Heater output 1. And the positive input terminal. Perfect. the fan positive, obviously not the fan negative, and the input terminal positive. Yeah, so that confirms that all the positive terminals are interconnected on the main board. So that means we can carry 1 or 2 up rather than having 1, 2, 3, 4, 5, probably 6 positive wires. That'll cut down the wire count quite considerably. Obviously, the stepper motor connections are fully independent of each other and the board, so they'll have to be carried up separately. So there's 4 wires dedicated to that. And then we've got 3, well, for the 2 fans, we'll have 2 separate negative wires because as we all know that it is the negative rail that is switched via the MOSFETs from the board, so they will have to come up separately unless you decide to run 2 things at the same time. Your mileage may vary, but yeah, a negative terminal for each of the outputs because they are switched separately. And then yeah, the sensor wire for the bed leveling. Let's see. Now VGS, these are the limit switches here, but then the bed leveling can come off one of those. I'd say it's one of the Z- or the Z positive terminals. I'm just going to double check to see if in fact, I might just put there we go, just to see if they're all connected too. So the top connector on the top pin on each of these connectors should be voltage. Okay, they're independent of each other, and they should be too because they're probably getting fed from the micro. But though the ground, let's have a look at the input negative. Yeah, they seem to be all separate too. Then again, oh no. So all the grounds are common from the limit switch point of view. Well, it makes total sense. Okay, so I'll quickly note down exactly what wires we need to carry up to this board from the control board area. In fact, I don't even know where this is going to be mounted as yet, but I'll decide that as I progress through this project.
Okay, time to fess up. The full wiring has been completed and the K8200 is back to fully operational and the basic tuning is completed. I just didn't feel like dragging the wiring of this too far, as it is tedious to do and even more tedious to watch.
Spacers!
Knowing I was changing out the 15.6 volt power supply to the 24 volt Meanwell knockoff, I wanted to do a profile assessment and the effect on the bed heating times. This was also a thinly veiled smoke test to see if the PCB heating element could withstand 24 volts and the higher power output. Starting with the 15.6 volts to test the default heating profile and get a baseline, I then rinsed and repeated the test with 24 volts. I do remember, however, the factory format of the K8200 was painfully slow to bring the bed to temperature and start the print. Let's see if we can fix that. This chart shows the 2 heating profiles, the orange line being the 15.6 volts and the blue being the 24 volt profile. We can see from this chart, as expected, the 24 volt profile gets to the target temperature much quicker. In fact, let's take 60 degrees C for example. At 15.6 volts, the build plate hits 60 degrees at about 12.5 minutes. Where the 24 volt profile reaches 60 in just under 5.5 minutes. That's about a 56% time saving over the factory setup. The difference in supply voltages is approximately 54%. This highlights a 2% increase in efficiency when compared to the time saving benefit. But this just could be a margin of error, as we did start the test with slightly different ambient temperatures. If you have any questions about this build, please put them in the comments below. Remember to like and subscribe as I try to reach 1000 subs by the end of June 2021. And with that, thanks for watching.
Well, let's solder all that in place and fit it up. Yeah, boy.